Hey guys, welcome back to my channel, and today I'm going to be showing you that this function is differentiable at every point in the plane. So starting off, we know a function can be differentiable if we can write it in terms of this. So delta z, where z is just f of x comma y, can be written in this form. And then as delta x comma delta y approach 0, our two epsilons should both approach 0. So if this holds true, we basically know that our function will be differentiable. So let's just try to show that. So in our case, our delta z would become f of x plus delta x y plus delta y minus f comma x y, because that's basically the definition of the delta z. So let's just plug everything in. So we get x plus delta x squared plus 3y plus delta y minus f of x comma y. So we get x squared plus 2x delta x plus delta x squared plus 3y plus 3 delta y minus x squared minus 3y. So these cancel out, and we're left with 2x delta x plus delta x squared plus 3 delta y. So we see that the partial derivative with respect to x is just 2x, so I'll just write it here. We can see that it's just 2x, so let's just write it here. So 2x delta x, and then the partial derivative with respect to y, we see is just 3, and that's over here. So I'm just going to write it here to make it obvious. And now this delta x squared can be written like this. And we're just going to do 0 times delta y because it helps us write it in this form, which is what we want. So we can just change our expressions to the partial derivative. So we get f x x y delta x plus f sub y x comma y delta y plus epsilon 1 delta x plus epsilon 2 delta y. So as you can see, epsilon 1 is just delta x and epsilon 2 is just 0. And as delta x and delta y approach 0 and 0, we see that these two also approach 0. And this just shows that f will be differentiable at every point in the plane. And yeah, we've basically proved it.